Not all atoms are neutral. So this carbon atom that I have depicted here, which has 6 protons and 6 neutrons in the nucleus, will have 6 electrons if it's neutral. However, if I add 1 electron, so 6 electrons plus 1 electron makes 7 electrons, then I will have 1 extra electron, 1 extra negative charge, and my carbon atom will have a negative charge. Atoms with negative charges are called anions. If I take 1 electron away, so 6 electrons minus 1 electron, I will have 5 electrons. Now I have 1 less electron than I need to balance the positive 6 charge in the nucleus, and so my carbon atom will have an extra positive charge and will be positively charged. Atoms that are positively charged are called cations. The periodic table is a very useful tool for helping us to determine the type of ion that the main group elements will make. Main group elements are those that are in column 1, 2, 3a or 13, 14, 15, 16, 17, and 18. Elements within a particular column have the same properties, and so elements within a particular column tend to make the same charge of ion. Furthermore, metals tend to make cations or positively charged ions, and nonmetals tend to gain electrons to make anions. The dividing line for metals versus nonmetals looks something like this. So elements to the left of that dividing line tend to make positively charged ions, and elements to the right of that dividing line tend to make negatively charged ions. This suggests that the elements in groups 1 and 2 will tend to lose electrons. In fact, it turns out that they tend to lose the number of electrons equal to their group number. And so group 1 tends to make positive 1 ions, and group 2 tends to make positive 2 ions. Nonmetals will tend to gain electrons to make anions, and they tend to gain the number of electrons that will provide 8 electrons in their outermost shell. So if we look at the noble gases, they already have 8 electrons in their outermost shell, and so the noble gases tend to make neutral atoms only. The elements in group 17, or 7a, already have 7 electrons in the outermost shell, so they tend to gain 1 and make negative 1 ions. In 16, they have 6 electrons in their outermost shell, so they tend to gain 2 to make minus 2 ions. The dividing line for the metals versus nonmetals kind of cuts groups 13, 14, and 15 in half, and so it's a little bit variable what ions those groups might make, but if we look at just the nonmetals, they tend to make negative ions more readily than positive ions, and the metals to the left of the line tend to make positive ions more readily than negative ions. Again, they will, if they're going to lose electrons to make cations, positive ions, they will lose the number of electrons in their group. So aluminum would tend to make +3, and gallium +3, and so forth and so on. If they're going to make negative ions, the rule is still that they will gain the number of electrons that will bring their outermost shell up to 8. And so, for instance, nitrogen with 5 electrons in its valence shell might gain 3 electrons to become -3. Carbon might gain 4 electrons to become -4. And boron might gain 5 electrons to become -5, although that's fairly rare.